So in today's video we're gonna learn about the calculation of n factor. So first of all we're gonna talk about the acids. How do we calculate the n factor of acids? So for acids, n factor is defined as the number of H plus ions that are being replaced by 1 mole of acid in the reaction. So the number of H plus ion replaced by 1 mole of acid. So like if we have H2SO4, in case of H2SO4, how much H plus is being replaced by NaOH? It could be 1 or 2. So n factor could be 1 or 2. Let's see a reaction. H2SO4, here it is reacting with NaOH and it is forming like NaHSO4 plus H2O. So in that case the n factor is coming out to be 1. Like if we are reacting with 2 moles, then n factor will be 2 because both of the H is being replaced. So actually if it is just asking what is the n factor of H2SO4, then we will be writing the maximum number of H plus replaced, then that is equals to 2. So here the maximum number of H plus are replaced is 2. Now let's see an example like H3PO4. Here if it is asking, it has only been given like H2PO4 molecule and it is asking the n factor. So in that case the n factor will be maximum number of H plus replaced, and here we know it is 3 H could be replaced. If we look at the structure H3PO4, it does look like this. So here we can replace maximum number of 3 H plus. Now if we talk about H3PO3, in that case if we look the structure P double bond OH and H, here n factor is coming out to be 2 because we could see only 2 H plus could be replaced from here. So that is coming out to be 2. Now if you look the reaction, like what is the n factor, let's see an example of H3BO3. We know it is a Lewis acid. So what could be the n factor? So as we know, boron has OH, these 3 OH over here, and it is reacting with H2O. So that's how it is reacting with H2O. So then H2O is acting as a Lewis base here, and it is a Lewis acid. So when it will gonna react, it will be forming like B, then OH, then OH, then OH over here, then OH over here also, with a negative charge over here, with HO. Okay, it is H3O plus. So here if you see 1 mole of H3BO3 releasing only 1 mole of H plus. So here n factor is equals to 1. Here n factor, we could say sometimes as a valency factor, here it is coming out to be 1. Now we gonna look again the bases. How we calculate the n factor of base when we have a base. So again we see for bases, n factor is defined as the number of OH minus ion replaced by one mole of base in the reaction. So here again it is defined as the number of ions. If we have base, how many OH minus it could have. So if we look at zinc hydroxide, Zn OH whole twice, here n factor we will be writing it as a 2. Now if we look like a calcium hydroxide, it is forming 2. If it look like aluminum hydroxide, again if we see aluminum hydroxide, the number of OH ion it could release is equals to 3 OH ion it could release, or it could be like, or it could be 2, or it could be 1. If it is asking, it could be 2 or it could be 1 also, and here it is 2 or 1, but it is asking directly, so we will be writing the maximum. It will be 2, 3 or 2 without reaction if it asking. Like if we write ammonium hydroxide NH4OH, it is we know it is 1, it is fixed. So that's how we do calculate for bases. So here we gonna talk about salt which reacts such that no atom undergoes change in oxidation state. Like if we talk about, if we have a salt like NaHSO4, here NaHSO4, if we look at in this type of cases, we calculate either calculate the charge on cation or calculate the charge on anion. They must be equal. So whenever we are talking about a salt which is not changing, undergoes change in oxidation state, so in that calculus we know when it is a salt it must be a neutral. When it is a neutral, so charge on cation should be equals to the charge on anion. And if you look any reaction like this over here, like Na3PO4 reacting with barium chloride BaCl2, and it is forming NaCl plus Ba3PO2, okay, Ba3PO4 minus then 2. So now what is the N factor of Na3PO4? We know it is a salt and then charge on cation, or we could say the from 2 moles, from 6 mole of cationic charge replaced by 2 moles of Na3PO4. Now just look at this case. Here we know all the cations are replaced. Okay, so without balancing, if we want to talk about the N factor, or we know whole barium has replaced like sodium, and sodium has replaced the barium. In that case we will be writing here N factor here is 3. How it is 3? Because we know the negative charge here it is minus 3, and the total positive charge here it is plus 3. They must be equal. Okay, so we will be writing its modulus. Here what is the N factor of barium chloride? It is 2. Okay, here N factor of NaCl it is 1, and here N factor of Ba3PO4 minus 2 is